In this video, let me explain tests for symmetry. How do we check symmetry with respect to x-axis, y-axis and origin? Alright, first x-axis. Replace y by negative y in the equation and simplify. If an equivalent equation results, the graph of the equation is symmetric with respect to the x-axis. Y-axis. Replace x by negative x in the equation and simplify. If an equivalent equation results, the graph of the equation is symmetric with respect to the y-axis. Origin. Replace x by negative x and y by negative y in the equation and simplify. If an equivalent equation results, the graph of the equation is symmetric with respect to the origin. Alright. So let me explain this using some examples. First example, I consider y equal x to power 4 minus 1. First, let me check with respect to x. Alright, so x-axis. So go back to the definition. X axis, replace y by negative y. Replace y by negative y. So what I do, I replace y by negative y. Then this become negative y. Negative y equal x to power 4 minus 1. So do you have the equivalent equation? No. These two are, I say this is 1. First equation and this equation are different. Therefore, this is not symmetric with respect to the x-axis. Now, let me check with respect to the y-axis. Right. Y-axis. Replace x by negative x. Okay, let me replace x by negative x. So, this is y. This equal negative x. Actually, negative x to power 4 minus 1. What is the negative x to power 4? So, if I explain over here, this one negative x to power 4, this equal negative x time negative x time negative x time negative x. So, negative x time negative x, x to power 2. It's a positive, pure negative, negative, positive. Then, x to power 2 times negative x. So, it becomes negative again, but x to power 3. Now, negative x to power 3 times negative x. Yes, negative, negative, positive. Therefore, we have x to power 4. So, this is x to power 4 minus 1. So, now you see equation number 1 and the equation we have here over here are the same. So, we can say this is symmetric with respect to y. Now, let me check for the origin. Okay, how do we check around with respect to origin? Over here, you see, read this, replace x by negative x and y by negative y. We have to replace both x and y. Okay, then y negative y equal negative x to power 4 minus 1. So this equal negative y equal this x to power 4 minus 1. So you see this is different from the number 1, equation number 1. Therefore, this is not symmetric with respect to origin 2. Next example, y equal x to power 2 minus 3x minus 4. First, we will check for x-axis. I write down this is x. So go back to this x-axis, replace y by negative y. Okay, so I just replace y by negative y. Then it become negative y. Here same x to power 2, it doesn't change, minus 3x minus 4. So I take this is equation A. So equation A and this equation are not the same. They are different. Therefore, we can decide this equation is not symmetric with respect to the x-axis. So then let me check for the y-axis. Go back to this y-axis, replace x by negative y. So I will replace x by negative y. Therefore, y equal negative x to power 2. Here actually use bracket. Minus 3, then negative x, negative 4, minus 4. So here negative x to power 2 is x to power 2, which is positive. Here negative 3 and negative x. So it becomes positive now. Therefore 3x minus 4. Now you see this is not the same as equation A. Here negative 3x here and here positive 3x. Therefore this equation is not symmetric with respect to the y-axis. The last one, origin. So replace x by negative x and y by negative y. Okay, so I replace y by negative y here. This equal negative x. This is negative x to power 2 minus 3x. It is negative minus 4. So we will have y, it is negative y equal x to power 2 minus, no, it is negative 3 and negative x, positive 3x plus 3x minus 4. Again you see this is not the same as equation A. Therefore we can say the graph has none of the indicated symmetries. The graph has none of the indicated symmetries. In my next video, we will study a certain type of equation that contains two variables, which is called a linear equation. Thanks for watching this.